and vice versa. So an example, just some sequence where we're switching, pattern is not crucial, just switching positive, negative, positive, negative, positive, negative, or negative, positive, negative, positive, negative, positive. Switching between positive and negative numbers. And number 4 is recursive. It's hard to get an exact key word here, but recursive is a sequence where each term is defined as based on the previous term. And I'll show you an example in 1 second. And by way of example, let's do a homework problem. Level 3, problem 2. Level 3, number 2. Hey, can you hold your chair, please? Thanks, buddy. There should be some strips somewhere down here. Thanks, buddy. You're good. Thanks. So, level 3, problem number 2. So that is right here. I think these directions didn't make it onto the page last night. Find terms 2, 3, and 4. That should be the directions for level 3. Okay. So, let's take a look at this problem. So they give you the general form. They say a(n) equals 2, a to the n minus 1 plus 1, and they tell you a1 is 1. So a recursive sequence, again in words, then we'll do the example, is a sequence where you have to have the previous term, so you have to know like a25 to get a26. You have to know a31 to get a32. You have to know a106 to get a107. This is what I mean by recursive. In the previous example we did not have to know that, right? We just got a100 on our own. We didn't need a99. That's a difference. So how does this work? If I want to find a2 is equal to, just plug a 2 in for n. So I have 2, a to the 2 minus 1 plus 1. This 2 minus 1 is called a subscript. Subscript means, sub means below, script is right, to right below. So let's simplify. This becomes 2. Instead of a to the 2 minus 1, that just becomes a to the 1. Or a of 1, or a1 if you want to solve it that way. Plus 1. The plus 1 is here. a1, they already told us, is equal to 1, so I'm just going to plug that in. So I have 2 times 1 plus 1, which equals 3. So a2 equals 3. Abel?
How'd you get from 2a?
Right here?
Yeah.
To here?
Yeah.
So I just saw the 2 minus 1 down here. And this 2 minus 1 is just 1. So then it just becomes, instead of a 2 minus 1, it's just a1. And then for a1, I already have the. So for a3, I'm just going to plug in 3 for n. So it'll be 2 times a3 minus 1 plus 1. 3 minus 1 downstairs in the subscript becomes a2. Plus 1 is still hanging around outside. a2 is 3. We already got that. So 2 times 3 plus 1 equals 7. How did I get 3? Like here? I just plugged in A2 from here.
Oh, okay. Because I plugged in 2 and 6 got 2 minus 1.
Yeah. So it is A2, but then you gotta find what is A2, and A2 is 3.
Oh, okay.
We got that from before. And the last one, A4, 2 times A to the 4 minus 1 plus 1. Notice this 1 out here is just a regular number. These are the subscripts underlined in blue. Subscript to right below. So what do we get? We have 2 times A subscript of 3 now. Plus 1 is still outside. 2 times A3 is 7. Plus 1 equals 15. Questions on recursive? Shunli? Right, so we said those directions did not print out, so please write them in. Find terms 2, 3, and 4. And the last one I want to do is level 2, problem 5. And they have g sub n equals x to the 2n over 2n. And they want us to find the first 4 terms and then the 100th term, and then determine what kind of sequence it is: arithmetic, geometric, recursive, alternating, or none. Excuse me. And so I think most of us should be able to do the first 4 terms and the 100th term. I'll be modeling it up here. Feel free to work and check your work with mine. Term 1 is on the board. I'm now moving to term 2. Move at your own pace. And feel free to check up here. Raise your hand if you have a question. You're a little bit confused how I'm getting something. Feel free to ask. Okay, and again, once you get all the terms, then your job is, no need to shout it out, but you got to see which type of sequence do we have here. Yeah. So the question is, you got to see which one of these. That's part of the problem. Yep. No need to say it yet. Any questions on generating the terms? Okay. Which of these types of sequences do we know has to be wrong? Just raise your hand and give us one that has to be wrong. Shunli, which one that has to be wrong? Arithmetic. Why does that have to be wrong? I forgot the I here. Okay. Why does this have to be wrong, Shunli? You're right. Because there's nothing I'm adding to get from term to term. George, what else has to be wrong?
Alternating.
Why?
Because you're not switching from negative to positive.
Great. What else has to be wrong, Brianna? Why? Yeah, I mean, like, we got G100, we didn't need G99. So the question is this geometric or none? Somebody defend why they picked what they picked. Why did they pick what they picked? Leslie, on.
I
Why? So you're saying you saw that we started here, and then we went to here, and then we went to here. So what did I multiply? I just did from here to here? You're saying from term 1 to term 2. Omar, support? So, so Omar said we started here with term 1, then he said here was his, this is A1, his common ratio in pink was x squared over 2, and what did he get then? He got x to the 4th over 4, which absolutely right is term 2. But then when you multiply again, we're going to have a little bit of problems here, because the ratio has to be the same throughout. The problem is downstairs, so we are not geometric, so it is none. Huh? But x squared over 2 plus x squared over 2 is x squared over, is 2x squared over 2, which is not the same. Alright folks, so there we have it.